Here, where the land meets the vast, shimmering ocean, lies a small community. They live by the rhythm of the tides and the warmth of the sun. The air is fresh, filled with the scent of salt and wild coastal plants. This is the village of Brightwater, a place where people have always looked to the sea for their livelihood. For generations, fishing has been their mainstay, the boats returning with silver catches. But now a new kind of harvest is beginning, one that draws its bounty not from the creatures of the deep, but from the very water itself. The coastline here is a marvel of natural engineering. Low, flat expanses stretch inland, perfect for capturing the sun's energy. These natural salt pans, sculpted by wind and water over millennia, have inspired a new generation. The people of Brightwater are resourceful. They observe the world around them with keen eyes. They have seen how the sun, in its relentless journey across the sky, leaves behind glittering crystals of salt in shallow pools after a high tide. This simple observation, this understanding of nature's own processes, is the seed of their remarkable endeavour. Life in Brightwater is unhurried, yet purposeful. The community is close-knit, families working together, sharing knowledge passed down through the years. There's a deep respect for the environment, a recognition that its health is directly linked to their own prosperity. This philosophy guides their new venture to extract valuable chemicals from the seawater, not through harsh industrial force, but by working in partnership with the elements. It is a gentle approach, one that seeks to learn from nature rather than dominate it. This innovative spirit, combined with an ancient wisdom of the sea, defines the people here. They are pioneers in their own quiet way, turning to the endless ocean and the ever-present sun. These are their primary tools, their abundant and renewable resources. Their efforts are a testament to human ingenuity, a demonstration of how even the simplest of natural phenomena can be harnessed for the benefit of humankind, all while treading lightly upon the earth. They are showing us a path forward, a way to live sustainably. The world's oceans are a vast liquid treasure chest. They cover more than 2/3 of our planet's surface. Within this immense volume of water lie dissolved minerals and salts, a chemical soup of incredible complexity and richness. For centuries, humanity has primarily harvested salt, the most obvious of these treasures. But the sea holds so much more: magnesium, potassium, bromine elements vital for agriculture, medicine and industry, all swirl unseen within every wave that crashes upon the shore. These are the hidden gems we are now learning to gather. Extracting these dissolved substances is not a new idea. However, traditional methods often require significant energy. They can sometimes involve processes that are less than kind to the delicate marine environment. The challenge has always been to find a way that is both efficient and gentle. The people of Brightwater believe they are unlocking such a method. By using the power of the sun, they are tapping into a natural cycle of concentration, a process that has been occurring on Earth for eons, long before human beings ever walked its shores. The significance of this endeavour extends far beyond the needs of a single small community. As the world's population grows, so does the demand for these essential chemical building blocks. Finding sustainable sources is paramount. The ocean offers a near inexhaustible supply, if we can only learn to harvest it wisely. This is not just about economics, it is about stewardship. It is about understanding that the planet's resources, even those as vast as the ocean, are not limitless unless we use them in a way that respects their natural cycles of renewal. Consider the sheer scale. Every cubic kilometre of seawater contains millions of tons of dissolved solids. It is a staggering thought. The potential to reduce our reliance on mined minerals, often extracted at great environmental cost, is immense. If we can perfect techniques like those being pioneered here in Brightwater, we could transform our relationship with the planet's chemistry. We could move from a model of extraction and depletion to one of gentle harvesting and sustainable use, a true partnership with the natural world. The heart of Brightwater's operation lies in a series of carefully constructed evaporation ponds. These are not complex industrial structures. Instead, they are shallow, expansive basins, sculpted with an understanding of the local landscape. They resemble the natural salt pans that dot this coastline, but are designed with greater precision to maximize the sun's evaporative power. The ponds are laid out in a sequence, each one playing a specific role in the gradual concentration of the seawater. It is a system born of observation and patient refinement. The construction materials are simple, locally sourced wherever possible. The base of the ponds is often lined with a dark, durable material. This serves two purposes. It prevents the precious brine from seeping back into the earth, and its dark color helps to absorb more of the sun's heat, thereby accelerating evaporation. The walls of the ponds are low, earthen berms, carefully shaped to control the flow of water from one pond to the next. It is a form of civil engineering that works in harmony with the contours of the land rather than imposing itself upon it. One can see the thoughtful design in every aspect. Windbreaks made from woven reeds or hardy coastal shrubs are sometimes strategically placed. These help to reduce the cooling effect of the wind on the surface of the water and also minimize the loss of fine, dry salt crystals on breezy days. Channels and simple hand-operated sluice gates control the movement of brine. This allows the operators to manage the concentration levels with remarkable accuracy, guiding the seawater on its journey from the ocean to a rich, mineral-laden solution. These facilities are a testament to the idea that technology does not always need to be high-tech to be effective. Here, human ingenuity has amplified a natural process. The sun provides the energy, the wind assists, and the carefully designed ponds provide the stage for this slow, silent alchemy. It is a place of quiet industry, where the only sounds are often the lapping of water, the cry of a seabird, and the gentle hum of nature at work. The ponds themselves seem to breathe with the rhythm of the day and the seasons. The primary ingredient in this remarkable process is, of course, seawater. It is drawn directly from the clean, clear coastal waters near Brightwater. Care is taken to ensure the intake point is free from pollutants and excessive sediment. Sometimes a simple filtration system, perhaps using layers of sand and gravel, is employed at the initial intake. This removes any larger particles, seaweed or marine debris, ensuring that only the water and its dissolved salts enter the first evaporation pond. This initial step is crucial for the purity of the final products. Beyond the seawater itself, very few other materials are consumed in the main process. The dark lining material for the ponds is chosen for its longevity. With proper care, it can last for many years, minimizing waste and the need for frequent replacement. The tools used by the workers are often simple hand tools, rakes for harvesting the salt, shovels and wheelbarrows. There are no complex chemicals added to hasten the evaporation. The sun and the design of the ponds do all the heavy lifting. This commitment to simplicity is key to the sustainability of the operation. The sun, that great nuclear furnace in the sky, provides the inexhaustible energy that drives the entire system. Its rays beat down on the surface of the shallow ponds, day after day. This solar energy is captured as heat, warming the water and encouraging the water molecules to escape into the atmosphere as vapor. No fossil fuels are burned, no smokestacks pollute the air. It is a clean, silent and utterly renewable source of power, perfectly suited to this coastal environment where sunshine is often plentiful. This reliance on solar energy makes the entire process exceptionally green. The other vital ingredient is human ingenuity and patience. The workers at the Brightwater facility must understand the nuances of the weather, the strength of the sun, the direction of the wind, the likelihood of rain. They monitor the salinity of the brine in each pond, deciding when to move it to the next stage. This is not an automated factory, it is a hands-on operation that requires skill, experience, and a deep connection to the natural rhythms. Their knowledge, passed down and refined, is as crucial as the sun and the sea themselves. Section 5. The Evaporation Ballet, a Slow Transformation. The journey of seawater through the Brightwater facility is a carefully choreographed dance, a slow ballet of evaporation and concentration. It begins when fresh seawater is pumped or channeled into the first and largest of the evaporation ponds. Here, under the relentless gaze of the sun, the process of transformation commences. Water molecules, energized by the solar warmth, begin to escape from the surface, leaving the dissolved salts behind. The volume of water slowly decreases, and the concentration of salts gradually begins to rise. As the water evaporates and the brine becomes saltier, it is moved sequentially through a series of smaller, progressively shallower ponds. This movement is often achieved by gravity, with ponds arranged in a slight gradient, or through simple, manually operated sluice gates and channels. Each pond in the series represents a further step in the concentration process. The operators carefully monitor the specific gravity or density of the brine. This tells them when it is ready to be transferred to the next pond in the sequence, ensuring optimal conditions for fractional crystallization. Eventually, the brine reaches a point of saturation where the least soluble salt, sodium chloride common table salt, can no longer remain dissolved. It begins to crystallize out of the solution, forming a shimmering crust on the bed of the crystallizing ponds. This is the first major harvest. Workers carefully rake the salt crystals into neat piles, allowing any remaining brine to drain away. This salt is of high purity, often retaining a subtle flavor of the sea, prized by chefs and consumers alike. The process is gentle, ensuring the crystals are well formed. But the process does not end with the harvesting of sodium chloride. The remaining liquid, now known as bitterns, is even richer in other more soluble minerals. This bittern is carefully drained from the salt crystallization ponds and moved to yet another series of specialized ponds or tanks. Here, further evaporation, sometimes aided by slightly different techniques, encourages the precipitation of other valuable compounds such as magnesium salts, potassium salts, and bromides. Each step is precise, a patient separation of elements guided by the laws of chemistry and the power of the sun. Section 6. Crystals of the Sea. The Precious Harvest. The total yield from the Brightwater solar evaporation facility is impressive, especially considering the gentle, low-energy methods employed. From every 1,000 litres of seawater processed, the community can expect to harvest a significant quantity of materials. The most abundant product, naturally, is sodium chloride or common salt. Typically, around 25 to 30 kilograms of high-quality sea salt can be produced from this volume of seawater. This salt is not only used for culinary purposes, but also has applications in preserving food and even in some local crafts. Following the extraction of sodium chloride, the remaining bitterns yield further treasures. Magnesium compounds are next in line. From that same 1,000 litres of seawater, several kilograms of magnesium salts, primarily magnesium chloride and magnesium sulfate, also known as Epsom salts, can be harvested. These compounds are highly valued, Magnesium is essential for plant and animal health, and its salts have numerous applications in medicine, agriculture, and industry. The careful separation ensures these magnesium salts are of good quality. Potassium salts are also present in the bitterns, though in smaller quantities than magnesium. From our initial 1,000 litres of seawater, perhaps a few hundred grams to a kilogram of potassium-rich salts might be extracted. These are often a mix of potassium chloride and potassium sulfate. Potassium is a vital nutrient for plants, making these byproducts incredibly valuable as a natural fertilizer for local farms and gardens, helping to improve soil fertility and crop yields without resorting to synthetic alternatives. This creates a beneficial local cycle. Finally, even more concentrated bitterns can yield bromine. While the quantity of bromine itself is relatively small, perhaps tens of grams from 1,000 litres, its compounds are valuable. Bromine compounds have uses in flame retardants, water purification, and pharmaceuticals. The ability to extract even these trace elements demonstrates the thoroughness of the Brightwater process. Each fraction, carefully separated, finds a purpose, ensuring that very little of the ocean's initial gift goes to waste. The efficiency lies in this complete utilization. Section 7. Gifts from the deep. The value of each element. Each compound carefully coaxed from the seawater at Brightwater holds its own intrinsic value, contributing uniquely to the community and beyond. Sodium chloride, the familiar sea salt, is perhaps the most widely understood. Beyond its essential role in the human diet and food preservation, it is a cornerstone of many chemical industries. Locally, it provides a high-quality product for consumption and trade, enhancing the flavor of food and supporting traditional methods of curing fish, a staple of the Brightwater diet for generations. Its purity is a hallmark of this gentle harvesting. Magnesium, harvested as magnesium chloride and sulfate, is a true multifaceted marvel. Magnesium is vital for human health, involved in hundreds of biochemical reactions in the body. Epsom salts, or magnesium sulfate, are well known for their therapeutic uses in baths, easing muscle soreness and promoting relaxation. In agriculture, magnesium is a key component of chlorophyll, the molecule that allows plants to convert sunlight into energy. Thus, the magnesium from the sea directly contributes to greener gardens and more productive local farms, boosting food security. The potassium salts extracted are a boon for local agriculture. Potassium is one of the 3 primary macronutrients required by plants, crucial for overall plant vigor, disease resistance and fruit development. By returning potassium from the sea to the land in a natural form, the community enriches its soil sustainably. This reduces the need for imported industrially produced fertilizers, which can have a larger carbon footprint and potentially negative environmental impacts. It's a closed-loop system, enhancing local self-sufficiency in food production. Even the smaller quantities of bromine compounds have their place. While their direct use within a small community might be limited, they represent a valuable commodity that can be traded. Historically, bromine was extracted from seawater on a larger industrial scale for photographic chemicals and anti-knock agents in aircraft. In the context of Brightwater, it represents the completeness of their extraction philosophy. To utilize as much of the seawater's dissolved wealth as possible, demonstrating a comprehensive understanding of the ocean's complex chemistry. Section 8. A gentle hand comparing old ways and new. The solar evaporation method employed at Brightwater stands in stark contrast to many conventional chemical extraction processes of this era. Standard industrial methods for obtaining chemicals like magnesium or bromine often rely on complex chemical reactions, high temperatures, and significant energy inputs, typically from burning fossil fuels. These processes can involve mining minerals from the earth, which disrupts landscapes, or using reagents that themselves have an environmental cost in their production and disposal. The Brightwater approach is fundamentally different. The beauty of solar evaporation lies in its simplicity and its minimal environmental footprint. It harnesses a natural, ongoing process, requiring little more than intelligent design and patient human oversight. There are no harmful emissions released into the atmosphere, no toxic byproducts that require careful and costly disposal. The only waste product is fresh water, returned to the atmosphere through evaporation, ready to fall again as rain. This makes it an inherently clean technology, a way of working with nature's cycles rather than against them. Consider the energy equation. Traditional chemical plants are often vast consumers of electricity or heat, contributing to the demand on power grids or requiring their own dedicated fuel sources. The Brightwater facility, by contrast, is almost entirely powered by the sun. This dramatically reduces its operational costs and, more importantly, its impact on the environment. In an age where concerns about pollution and resource depletion are beginning to grow, this reliance on renewable solar energy is truly forward-thinking, a beacon of sustainable practice. Furthermore, the quality of the products can also differ. Salt, produced by rapid, high-heat industrial evaporation, might lack the complex trace mineral profile of sun-dried sea salt, which many believe contributes to its superior flavor and nutritional benefits. The gentle, slow crystallization at Brightwater allows for the formation of well-defined crystals and helps to preserve these subtle but important qualities. It is a method that prioritizes quality and environmental harmony over sheer speed and brute force, a philosophy that resonates deeply with the ethos of the community. Section 9. Waves of Change, a future powered by the sun and sea. The achievements at Brightwater are more than just a local success story. They offer a ripple of hope, a vision for a more sustainable future. The benefits to this small seaside community are clear and immediate. New livelihoods have been created, diversifying the local economy beyond traditional fishing. The harvested chemicals provide valuable resources for local use, from enhancing their food to enriching their soil, fostering a greater degree of self-sufficiency. This empowers the community, giving them control over essential resources. The environmental benefits are equally profound. By adopting a process that is powered by the sun and produces no harmful waste, Brightwater is demonstrating a deep respect for the marine and coastal ecosystem upon which it depends. This gentle method of extraction ensures that the ocean remains a healthy, vibrant resource for generations to come. It is a practical example of how human industry and environmental stewardship can go hand in hand, a vital lesson for a world increasingly grappling with the consequences of unsustainable practices. The potential for broader adoption of these solar harvesting techniques is immense, particularly in coastal regions blessed with abundant sunshine. Imagine similar facilities dotted along suitable coastlines around the world, providing essential minerals and salts with minimal environmental impact. This could reduce our reliance on energy-intensive mining and chemical synthesis, lessen pollution, and help communities become more resilient. The principles are scalable, adaptable to different local conditions, offering a pathway to cleaner chemical production globally. The work at Brightwater is, in essence, an inspiring testament to human ingenuity working in concert with nature. It shows that by observing and understanding natural processes, we can develop innovative solutions to meet our needs without compromising the health of our planet. These sun-drenched ponds, patiently transforming seawater into valuable crystals, are not just producing chemicals, they are cultivating a new way of thinking, a brighter, cleaner, and more harmonious relationship between humanity and the great life-giving ocean.